Okay, now we're gonna look at another concept. And here, so let me just reduce the friction. So here, you're exerting a force on this crate, so that you're doing some work on it. So you're giving your energy to that crate, and when you let go, the crate is gonna keep on sliding. So it's still gonna be moving after you stop doing work on it. And let's look at a more realistic case. Let's add friction. So if we add friction, let's see what happens here. So you're gonna do work on it. It takes some effort because at first it doesn't move. You have to do effort. But as long as you, when you apply just enough force or over a certain amount, then you'll get that crate to move. And if you apply a lot, that means you're doing a lot of work. You're getting more and more tired. And you let go. So you stop doing work, but as you notice, the crate is still moving, which means that it can collide with something else and it can cause damage. So essentially, the crate has energy even though you're not doing work on it. And its energy is based on the fact that it's moving. So this is going to be the next kind of energy that we'll be looking at, the energy due to motion. So this is what the picture up top shows you. Something similar. What you have is the ground, and you have a crate. And let's say that you kick the crate. So your foot is going to be in contact with the crate for a while, and it's going to make it move over some small distance. So over the time that your foot is in contact with the crate, you're going to be doing work on that crate to make it move. But then the crate is going to fly off. It's not going to be in contact with your foot anymore, and it'll keep on sliding for a while. So it has some velocity v. So here we give the crate some energy. So we'll say we give the crate some energy by doing work on the crate. So that's the beginning part, and then later on the crate is still moving here. So at the end, so after, the crate still has energy. So it still has energy, but this energy is just due to its motion because it's moving. So we're going to introduce our next form of energy. So we're going to call this kinetic energy. So this crate is going to have a kinetic energy K. So we're going to define kinetic energy this is energy due to anything that's moving or anything with a velocity. So I won't derive the equation, but it comes out to be if an object has mass m and moving with the speed v, its kinetic energy is going to be 1/2 the mass multiplied by the velocity squared. And so this is a form of energy. So you can also write this as K sub E for kinetic energy. So because it's an energy, it's also going to have units of joules. So the next form of energy, let's look at this one now. This has to do with storing energy, the next case. So here, imagine that this is the ground, and you have a shelf up here. And a shelf is some height y above the ground. And let's say that you have a bowling ball or something really heavy, and you want to lift a bowling ball to place it on that shelf. So since the bowling ball is heavy, you're going to apply a force to lift it. You have to lift, and you're going to raise it to some height, to the height of the shelf, and you're going to drop it onto the shelf. So bowling ball is heavy, which means that you'll get tired because you had to raise that bowling ball up to that height. And because you got tired, that meant that you had to do some work. You have to do some work to raise the bowling ball to that height. But unlike the previous one, so here you did some work, and at the end, you got motion here. So the energy was in a form of motion for kinetic. Here again, you're doing work, but in this case, there's no motion happening. So we can say that actually what's happening is that the energy you did the energy you exerted, or the work that you did, got stored. So because you're not moving, but you did do some work, that meant that your energy got stored. So this stored energy, we're going to call this potential energy. So anything that, we'll look at it two different ways, but let me just write the most direct case first. So stored energy, another word for that is potential energy. And so the equation is, we define potential energy to be the variable U, and that's defined as the mass of the object times g multiplied by the height that you raise the object. So there's another way that we can look at potential energy. You can also define potential energy instead of using U. You can also say, you can call it also PE or P sub E for potential energy. Both mean the same thing. So one way that to look at potential energy is the energy that is stored. But another case is really anything that's above ground, anything that's not at ground level, has some energy just based on its height. So potential energy, you can say that it's stored energy, or really it's energy due to your height above the ground. So due to your height y, above the ground. So if this is the ground here, anything that's in the air that's not on the ground that has a mass m, and that's a height y above the ground, is going to have some energy just because of its height above the ground. So let's look at a combination of those two things then. So let's say that you have a soccer ball, and this is the ground again. And you're going to kick the soccer ball, so the soccer ball is going to fly and it's going to be in the air. So two things are happening when it's in the air. First of all, it's moving, it's going to have a velocity v. So because this has a velocity v, it's going to have some kinetic energy, or energy of motion. And the other one is because it's off the ground, it's some height y above the ground, it's going to have some potential energy, or PE, due to its height. So due to its height off the ground. So we can combine those two forms of energy and say that in general, the soccer ball is going to have a combination of both energy because it's moving and because it's off the ground. And so we're going to call this the general mechanical energy, or I'm just calling it energy. So the energy, or mechanical energy, is going to be your kinetic energy plus your potential energy. Or you can also write this as your kinetic energy plus your potential energy U. So your total energy, your total mechanical energy, is just a combination of your kinetic plus your potential.